The final thing in this session that I want to cover, which is to a certain degree a standalone, but it has relevancy, is what is termed the maximal lactate steady state. Now, I want to be absolutely clear. Maximal lactate steady state is not the same as the lactate turn point, is not LT2. And quite often they are intermingled. But it's important to understand the maximal lactate steady state because it really helps us lead into other sessions moving forward. And also because it kind of fits very nicely in terms of us talking about lactate. What is the maximal lactate steady state? Well, if we take this from Ralph Benneker, the maximal lactate steady state is the highest blood lactate concentration that can be identified as maintaining a steady state during prolonged submaximal constant workload. The workload corresponding to the MLSS workload presumably represents the highest submaximal exercise intensity that can be performed without an anaerobic energy metabolism. Above MLS intensity, the kinetics of the blood lactate concentration show a clearly identifiable increase with time during constant workload exercise. What is he referring to? Well, remember what we started in this class about, which was if you're below LT2, you're in steady state. So you would get a steady state concentration of lactate at any workload below LT2. If you go above LT2, remember I mentioned earlier the idea of heavy and severe. In the heavy domain, you get a steady state in lactate, but it's a delayed steady state in lactate. In other words, you'll get a steady state in lactate concentration in the moderate domain in about 3 to 4 minutes, pretty much in accordance with what you would see with the blood lactate response. But in the heavy domain, it's delayed. It may take about 6 to 8 minutes to reach a steady state. But go into the severe domain, you do not get a steady state in either VO2 or lactate, and in fact both rise inextricably to the point of volition exhaustion, that is the VO2 max. And the demarcation of the transition from heavy to severe, the point where you lose the steady state condition, one of the ways of demarcating that is by what is termed the maximal lactate steady state. So this is a representation from our data, and it's a slight adaptation from what Ralph published back in 2011, but I've superimposed it onto our data set. Here's our lactate threshold LT1. So here's our lactate turn point LT2 here. Could be here, but it might be here. And then you've got maximal lactate steady state, which occurs beyond that point, and it demarcates this heavy domain. So how do you identify it? Well, it's a very, very different approach. You firstly have to run an incremental test, and you have to identify where you think the LT2 response occurs at. And then, as Ralph has put in this paper here, which is a really nice paper that he published in the early 2000s, is you then on separate visits run a series of repeat steady state trials. And you'll notice what I was saying, that if you go, and you have to do these by the way above LT2, because remember LT2 demarcates the boundary between moderate to heavy. And notice what happens. The lactate concentration doesn't reach a steady state in 3 to 4 minutes. It takes about 10 minutes to reach steady state, which is why the early slides in this class were referring to the idea of potentially having 10-minute workloads. But we kind of suggested that perhaps is the efficacy of that's not great. But then what you do is you actually ask the participant to exercise for 30 minutes. And then you take the average concentration across this last period here. So this last 10-minute period, you take the average concentration. And what you have is you have a steady lactate concentration. On a separate visit, you increase the resistance. They've gone up by 20 watts here, and you do the same thing. They've gone up on another visit, 20 watts here. Now they've gone up by just 15 watts, and you see the effect. It's a non-steady state response, and they hit the point of exhaustion because they can't go for as long. So you get to this concentration here. Now, had they gone to 305, you may still have got a steady state response. So it's very much dependent upon the increase that you use. But this demarcates that boundary between steady state and non-steady state exercise, the boundary between heavy and severe. It is not the same as LT2, but it does allow us to now identify, which we'll get into in later classes, particularly the one on oxygen uptake kinetics. It does now allow us to identify a moderate domain below LT2, a heavy domain between LT2 and maximal lactate steady state, and a severe domain from maximal lactate steady state all the way up to the VO2 max.